Today's solution starts with three helper functions. The first one is borrowed from yesterday, where we simply split a string at new lines followed by spaces. And the second one shall cut a string in half, for example, A, B, C, D, E, F into A, B, C, and D, E, F. So let's start with a couple of let bindings. The length of the string would be count of S. The middle of the string would then be the length divided by 2. Let's say the front is then a substring of S starting at 0 going to the middle. So the first index is inclusive and the second one is exclusive. And the back would be a substring of S starting at middle and going to the very end. And maybe let's align that here nicely. Okay, and then we can simply put front and back in a vector. That would be this vector that you can see here. Let's see if the tests pass. Yeah, they already pass, so that's quite straightforward code. And then the third helper function, let's comment it in, shall determine the common letter in the strings passed in. So for the first part, we're given 2 strings, and for the second part, we're given 3 strings, and we can make it work for both parts with the help of the set function. The set function takes some collection, could be a string, for example, let's say, I don't know, hello, and then it gets turned into a set, and then Clojure has some useful set arithmetic in the standard library. So we want to map the set function over all our strings. Then we have 2 sets for part 1 and 3 sets for part 2. And then we want to intersect those sets. That would be set intersection. And then we get exactly the same result as before, because the set intersection function doesn't take a collection of sets, it takes individual sets as individual arguments. And now here we only passed a single argument. Okay, so basically we want to flatten the parameters contained in the sequence into individual parameters. And we do that with the apply function. And then we get a useful result, P contained in a singleton set and R contained in a singleton set. So we can simply apply the first function to that, and then the test also pass. Right, then our letters have priorities. The lowercase ones have 1 to 26 and the uppercase ones 27 to 52. You could do that with some clever ASCII arithmetic, but I chose the dumbest solution possible. The zipmap function takes keys and values as individual arguments. Keys is the first string, all 52 letters, and the values is this range here from 1 inclusive to 53 exclusive. If you don't trust me, 1 inclusive, 52 exclusive. Okay, and then if we simply look at that map, then you can see the A's are mapped to 27 and 1 respectively, and the Z's are mapped to 52 and 26 respectively. That looks quite good. Right, then we have the part 1 function. What do we have to do? So we start with our input string, and the first thing that we want to do, of course, is split it. So let's apply, or just call the split lines function on it. Then we have individual lines, and then we want to cut every string in half. So that would be map cut in half. Then you can see they were all cut in half. And what do we want to do then? Then we want to determine the common letter. So that would be map common letter. That looks very good. And now we want to know the priorities of all those letters. So that would be another map function. Priority looks like this. And again, we can use a map as a function passed to the map function as we saw yesterday. Okay, and then we want to add them all up. That would be again reduce plus 0, same as last 2 days. Okay, and that's quite a lot of code with multiple maps happening in succession, and that's also inefficient. So this map consumes memory, this map consumes memory, this map consumes memory, all in a lazy fashion, but not trivial. Okay, but we already know we can optimize that with the transduce function. First the transducer, then plus 0, and then our collection here. Okay, and the transducer is now a composition of 3 individual transducers. This would be the first one, the second one, and the third one. So maybe let's type that explicitly. Map cut in half, map common letter, and map priority. Now the order is from top to bottom. That's easier to read also, right? Here first we do cut in half, then common letter, then priority. First cut in half, then common letter, then priority. I think that's simpler to understand. And it also works and is more efficient. Okay, so then let's copy that down for the last part. So what is now different in the last part? We don't want to split every line in 2 strings. Instead, we want to treat 3 strings as a unit. So we have to choose something different here. Basically, we want to have partitions of length 3. That would be partition of length 3. Unfortunately, that doesn't work because the partition function does not have an arity that only takes an n. It has no transducer arity. But fortunately, the partition all function has one. Then all the tests pass again. And let's look at the transducer arity here. You can see it, right? Takes only a single argument, and then this is a dead giveaway function that takes a reducing function, and so on. Okay, note that this only works, let me put it this way. If the file ended here, then partition 3 would only look at these guys and not at the last 2, whereas partition all would also then treat the last 2. But since we're guaranteed that the number of lines is always a multiple of 3, there is no difference between partition and partition all in this particular example.